Last but certainly not least, we have an interesting problem. We have a proof. And this is a straight up reasons problem. They're not going to tell you how to prove it, they're simply going to say, prove it. And when you see that, you immediately got to be thinking a two-column proof, where you're going to have your statements, your reasons, and the first thing you're going to do is you're going to label your givens. So, what they give me is this fact. All right, that's the most important one. One, segment GI is parallel to segment MT. How did I know that? It was given. If you want, you can make another step where you say like diagram with info, but that's not really there, so I'm not going to do that. Most of these are just going to have one given fact that you need to use. And I'm going to recall that to prove triangles are similar, my three methods are side, 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 angle, side, and then angle, angle. And if you look at the diagram, they don't tell me anything about the sides. So that won't be a valid method. And nor is side, angle, side, because I know nothing about the sides. This is going to have to be an angle, angle problem. And right off the bat, I can see that these angles in here, I'm going to color them two different colors, right? Because this is going to belong to this blue triangle. All right, I know this angle here is got to be congruent to the angle in the red triangle. How did I know that? Well, these things are really vertical angles, right? When two lines intersect, they form angles. Those angles must be congruent because of the vertical angle theorem. And that's going to be my next statement. My statement 2 is going to be angle IAG, that angle right there. Angle IAG is congruent to angle TA. How do I know that? Well, those are vertical angles, and I'm going to keep track that that's an angle fact. I've got one out of the two angles that I need. And then the second pair of angles that are going to be congruent is going to depend on that given. Now that I see that this side is parallel to this side, I've got parallel lines cut by a transversal. Okay? And what you're going to do is you're going to look for that Z shape. Right? You're going to look for that Z shape. And in that Z, you're going to have those congruent angles. So right in here, there will be a congruent angle, and right in there will be a congruent angle. And that's because of parallel lines. So if I clean this up, angle G will be congruent to angle T. And that will be my third statement. Angle G must be congruent to angle T. And that's because these angles, when you have parallel lines cut by a transversal, these angles are called alternate interior angles. And I can just say alternate interior angles are congruent. And I don't have to state that the lines are parallel because I've already said that prior. When you say that the lines are parallel, it's understood that when you're going to be talking about alternate interior angles, you're talking about the ones made by the parallel lines. So that third statement establishes my second angle, which is all I need in order to prove what they asked me. So I've gotten enough information to invoke and to use the angle-angle postulate. So now I'm ready to restate. I'm just going to copy down what they asked me to prove. That triangle GIA is similar to triangle TNA. And how did I know that? Well, that is the angle-angle postulate. You could just leave it at angle, angle. You don't have to put that POST, but I'm feeling fancy, so I'm going to write postulate, or at least I'm going to abbreviate it. Thank you so much for watching Elias Academy Day 58, the final day of review for the DRA, which will be next week. If you have any questions, please reach out to me in class, through email, whatever. I'll get back to you, and best of luck. I'm looking forward to seeing the results on the DRA. Thank you.